Alright guys, so this video is for Algebra 2, and we are going to be looking at specifically the Z2 and Z4 IXL, so we're talking about the sine functions as graphs. So let's look at Z2 first. And we'll kind of run down a couple questions on each, and hopefully that makes it a bit easier when you guys go through it. So for Z2, it asks, write equations of sine functions from graphs. So basically we're going to take, this is like the parent version of the graph, so like the base version where there's values for A, B, and C, and D, and we're going to figure out what numbers go there. Since we're doing a screen capture here, I'm going to use some of these tools to try writing on the screen, and you guys will just have to kind of bear with me with the trackpad on this, and we'll see how it goes. I've already made an Algebra 1 video today, so it wasn't too terrible, but this is graphing, so it might be a little different. A couple things to look at for each one as we make this is, well, first we have to keep in mind that the base version of sine as an equation would just be sine, and then in parentheses x, and with nothing else there. So that would be like an amplitude of 1. This b value that they use here would be like 1. The c and the d would be like 0 because there wouldn't be anything tacked on. In this case, we need to think about this picture versus our normal graph. Well, normally sine starts at 0 and this one does too. By start, I mean it's at the origin here. It's not shifted up or down at all. So that tells me this value d is not going to be changed. We're not going to use one, basically. The c value is not going to get used much here because it's a phase shift, meaning this gets moved left and right. B relates, it's not exactly, but it relates to the period of the graph, basically how long it takes before, if you notice, like if I started right here, I'd follow up, down, and then it would start over, up, down, and if it kept going, it would start over. It's how long for one of those like start over periods. So from here, up, down to here would be one period. So in this case, it would be 360. That's not what goes here. Like I said, it's just related. If that period length is 360, or in radians 2 pi, that's when this is 1. The technical, like I guess you could say quote unquote formula there is 2 pi divided by like that b value, or 360 if we're talking about degrees like this. And then finally a is the amplitude. So that's from, you can think about it to the middle of the graph. So by middle, I mean like from like right here where my jagged line is to like the top. How far is that? Well, that's 2 units. So instead of being 1 is typically where it peaks, this would be 2. Another way of finding that is from the very bottom to the very top and then halving it. That seems like an extra step to me, but some people find that easier. So in this instance, that's our only change. That amplitude A is going to be 2 instead of 1. So what I would type in here is, it already has the f of x for me. I would type 2, and then sine, and then in the parentheses x. We didn't have any other changes here. That's still 1, so we don't even have to put it. We don't have a c or a d here. Okay, now if we look at the next one, there's some change to this. The first thing I'm noticing right off the bat is that instead of starting at 0, it's up at 1. So that tells me this d value is going to be 1. If it was down here, it'd be minus 1. But we potentially have more. Let's look at the period next. Starts here, goes up, down, and it would be right here before it makes it back to that middle ground. Well, that's 540 this time, not 360, so there's a little bit of math to be done here. kind of like we were just showing with 2 pi over b, or like I said, in this case, it's going to be 360 over b. So let's write that out here. And then to solve and figure out what goes for b, we put equals. The new period length is 540. If I multiplied both sides by b, I'll probably only show this once because it's a lot of writing with this trackpad. But we'll do it for one problem here. I think once you guys see all this stuff, the next IXL won't take a lot of explanation. If I multiply on both sides by b there, this one would cancel, leaving just the 360. This one would have 540 times b, and then to get b by itself, we would divide both sides by 540, leaving 360 over, I'm running out of space here, 540, oops, long 4, equals b. And then if I simplify that, like I'll plug that into my calculator, it's giving me 0.6 repeating. I know as a fraction, which is like what this is, that's 2/3. So what that would tell me is instead of using a 1 right here in this space, I would write 2/3. So that's, oops, thought it would do it for me. There we go. So that's at 2/3. And then finally, let's think about, like I said, we're not going to have phase shift much. Finally, let's think about A value amplitude. That's from the midline, so the middle of the graph, to the top. So how far is this? It's 1 block, but 1 block isn't one like 1 that we're counting with here. It's actually just a half, so that's going to be a fraction too. So out front, I would have 1 over 2, and then this should do it for me. Super, awesome. Okay, I think that's about, that last one was actually a really good example. It showed kind of everything there. It had a shift, it had a period change, it had an amplitude change. I don't know if there's much else here that we'll see, because from looking at this one, I'm seeing down 3, amplitude, we just talked about period length. It says 180, but you could set it 360 over b equals 180. You could solve that. That's kind of what we just talked about. From here it goes, starts up at 1. See how far apart it is? Okay, it looks like it's kind of the same idea for each of these. So let's go back to our menu, and let's go to Z4 and see if there's much of a difference. I think if you understand Z2, Z4 won't be much of an issue. So Z4, graph sine functions. So if we were in class, this is probably what I would tell you, like by the end of class, you should be able to graph sine functions. For sine functions, I don't know if they're trying to trip you up here or what, but this is the one we're going to go with. This is the sine function. This looks like cosine to me because it starts up. That's kind of my tell. And then this is closer to some of the like marble slide Desmos activities that we've done where we move the graph around, except this one's a little bit nicer because you can just drag and drop. This one you don't actually have to change at all because this is just the parent graph. There's nothing extra tacked on. When I hit this button, it gives me just the parent version, so I could just hit enter here and it would tell me great job, and I would have a little self-satisfaction there. This negative, that's something we didn't see from Z2. A negative in the amplitude, this is a -1, so I don't have to think about like stretching it at all. The negative though takes it and it flips it over, so it now goes down to -1 and kind of hits its minimum down there instead. So that's the only difference here. Now we're seeing amplitude changes. We're seeing flips and amplitude changes. We're seeing a period change, so you have to think kind of backwards from before. That's the b value. We would do like 360 divided by 2 that would tell me. I'll let you guys figure that out. How far before it needs to repeat again. Anything else in here? Negative, if it's in here, it also causes it to start down instead of up, so that doesn't change anything with the negative. And then B value again. Okay, and like I put on progress book, if you get to a 70, that's considered full points for this one. All right, if you guys have questions on this stuff, I know this is a little bit different platform here, let me know. Comment on here, or feel free to email, and I'll try to help you guys out, and we'll try to get some progress made over this extended break. All right, see you guys.